Hey kids, happy Tuesday with a Thursday feel. We are almost to the weekend again, so woo, go us. We're going to spend another day on segment proofs. I know all of our understanding levels are at different spots, and I apologize, I'm gone. I'm at EDC Cross Country in Fargo. So today I just want you to work hard. If you know what's going on and can explain something to a classmate or a friend, please do so. Help them, help each other. Just be good for the sub, okay? So we're just going to try to dig into these two proofs for notes today, and then we'll go from there. So let's see here. Okay, so it says, given AB is congruent to CD, prove that AC is congruent to BD. So again, we always want to mark our picture so we have a visual of what's happening. So it says AB is congruent to CD. Okay? And we want to prove that AC from here to here is equal from B to D. Okay. So I'm just going to color code these a little bit. So those are our green segments, right? And then I have AB and CD are the same. And then I just have this BC in the middle, right? So if you want to grab some colored pencils or some highlighters, if this helps you maybe visualize a little easier what's happening, go grab those. So we always want to brainstorm a little bit and just visually see what's happening, or can we write anything down for brainstorming? So I already know that AB, or those red segments, are equal to each other, right? That was free information that they gave us. And now let's just look at AC. Let's just look at this first green segment here, guys. Look, what two parts make that up? What two things make up that whole AC? Well, if I look, I know AC is equal to AB, that first red segment, plus BC. And now if I look at BD, this guy, what two things make up BD? I know BD is composed of what? CD plus BC. Now, let's look, folks. Do those two green segments, the AC and the BD, do they share anything? Is there anything that they have in common? Well, I hope you're thinking, yes, look, BC, look, this guy is in both of them. It's right here, and it's right here. So BC is equal to itself. And what else do we know? And we already know the two red segments, AB and CD, are equal to each other. So I think logically we can make sense that AC is equal to BD, right? They're made up of the same parts. So now let's just try to formulate a proof to see if we can correctly prove this, okay? You could do a two-column proof if you want. I personally prefer the two-column. I say you can do a flow proof, is what I meant. I like the two-column. It's just easier for me because I write so big, but it's up to you. You do what works best for you. So we already know that the first thing we always write down is our givens. So AB is congruent to CD, given. And now we have that weird notation thing again. We have to get rid of the congruence and segment symbol. So we're going to write the same thing, AB is equal to CD. And that, if you remember, is definition of congruence. Okay? So now we're here, and now I think it would probably make the most sense if we said what our segments are made up of, right? Because I want to show that those two things are the same, so I can set them equal to each other. So I'm going to tell you guys, or we're going to tell everyone, what makes up AC. Well, we know AC is made up of AB plus BC. And what makes up BD? Well, BD is made up of what? What two chunks? CD plus BC. And that's segment addition. Perfect. Okay, now let's just look here, folks. Look. What's in common? I have a BC, I have a BC. So now I'm just going to state, even though I know it seems really silly to have to say that the same thing's equal to itself, we have to. We can't leave any holes in our argument. So what is our reason why BC is equal to BC? Well, that is the reflexive property. And remember, reflexive looks like reflection. When you look in the mirror, it looks like yourself. Or you see yourself. Okay? And then if we notice up here, guys, look. We already said AB is equal to CD. Well, here's my AB and CD. So now I'm going to rewrite what my AC equals. So I'm going to write AC equals, but instead of saying AB right here, I'm going to replace it with CD plus BC. Because now that was substitution. I replaced something that was equal. Substitution property. Because now look what I did, everyone. If you notice, look here. I have AC equal to CD plus BC. And look right here, CD plus BC. Now these things are equal. So now I can finally say BD is equal to AC. I first had to show that AC was equal to the same thing that BD was. And now that I have, I can set them equal to each other. So now I'm going to write AC is equal to BD, and that's the transitive property. Look, we only have one more step, guys. Do you notice how I want to have AC is congruent to BD? So now, by using a little definition of congruence, I can write AC is congruent to BD. Definition of congruence. Okay, that wasn't totally awful, I hope. So that was our first one. I hope that was okay for you. It's hard talking to a classroom full of nobody. Let's try the next one. So how about you just take a quick second, pause the video lesson, read your givens, mark your picture, and do a little brainstorming. Or just think, you have to write it out. Just think of what would be a potential process that you would do. Okay? See how that goes. Did you pause it? So I'm going to get started. Okay, so it says C is the midpoint of AE. So I know if C is the midpoint, then that would make AC equal to CE. And then we're also given C is the midpoint of BD. Now that tells me BC is equal to CB. And AE is equal to BD. So really, folks, all those little segments we just marked are equal to each other. And I eventually want to show that AC, so this guy right here, is equal to CD. This is our goal, is I want to show that those two things are equal. All right, let's formulate some things here. So if I write out the first one, if C is the midpoint of AE, I know that AC is equal to CE. If C is the midpoint of BD, then BC is congruent to CD. And then, since AE is equal to BD, all of these are actually equal. So this one shouldn't even take that long, right? So just a couple stepper maybe? We'll see. We'll see how this works, okay? So let's write out our two columns, or you can make your flow proof, whatever you want to do. So again, I don't think this proof is that hard to think about. If I have 4 pieces that are all the same length, then obviously 2 of them would be equal, right? We just have to write the correct proof to show that without leaving any holes. So let's start off with your given. I know how easy it would be just to draw an arrow and go like this. Can't do that. Don't do that to yourself. Just write it out. I have to write it out too. So C is the midpoint of AE, but we can combine those two, and BD. And then we can also say that AE is congruent to BD. So those are our givens. Okay, just to take care of that definition of congruence, let's rewrite this. AE is equal to BD by definition of congruence. Perfect. Okay, so now let's go back up to the midpoint thing. So if C is the midpoint of AE, what two things are equal? Well, we would know that AC is equal to CE, definition of a midpoint. And then we would also know, if C is the midpoint of BD, that BC is also congruent to CD. For the same reason, definition of a midpoint. Perfect. So now we have some unique ways that we can show AC is equal to CD. I think the easiest way is it's kind of like the last proof we just did. Can we show I'm going to run out of room here. What parts make up AE? So if I do AE, what makes up AE? Well, AE is made up of AC plus CE. Okay, and then what makes up BD? Well, BD is made up of what? BC plus CD, and that's just segment addition. And now from here, okay folks, if we look up a few steps ago, we said that AE is equal to BD. So now, since I rewrote AE and BD, I'm going to substitute in. So now I'm going to say, since these two things are equal, I'm going to write what they're equal to each other. So AC plus CE equals BC plus CD. That's just substitution. I substituted in for both of them, substitution property. So now my goal is to rewrite this only using AC and CD. Okay, well, do I know anything about CE? What do I know about CE? Well, I know CE is equal to AC. So now I can write AC plus AC is equal to, now, do I know anything about BC? Well, BC is equal to CD. So now I can replace a CD for that BC. Oh boy, there's a lot of letters going on. So all I did was substitute in for equal things. And now from here, it's super simple. We've done the hard part, and now we just have to finish it off. How many ACs do I have here? 2. So when I simplify, I'll have 2 AC is equal to how many CDs? 2 CDs. That's just simplifying. We simplified. Now, if I just want to have one AC, how do I get rid of that 2? Well, I would divide. If I divide to one side, I have to divide to the other. So the division property. And lastly, I want to say that those segments are equal. So by definition of congruence, we could say that AC is congruent to CD. Definition of congruence. Okay guys, I hope that maybe filled in a few of our gaps or maybe made you more confused. I don't know. I really wish I could see your faces just so I could tell myself. But here's the deal. Now I want you to do the quizzes that I posted in Google Classroom. Once you have finished the quizzes, show Miss Gasparini your score so she knows you've completed it. And then she will give you your green worksheet, okay? Try your very best. Don't come tomorrow to class with not trying anything. You need to at least try, and then we can go over things that we need to. Have a super great day. We'll see you tomorrow. Maybe.